I'm going to prepare this spindle block ready for a chuck, so I'm going to compress down onto a tenon. I'll put a tenon on both ends and I'll form both in two different ways. But first I need to rough it down to the round, so I've set my tool rest height, my distance, and using a spindle roughing gouge, the ideal cut for this particular tool, I'll rough it down to the round, ready to put the tenons on. Here I have a choice of two tools to use to put my tenon on. I have a 40-40 bowl gouge with straight wings and a 3/8 beading and parting tool. Both have 40-degree cutting edges, and I'm going to form a tenon on each end, one with each different tool. With the bowl gouge, I was able to clean up the face here first, then cutting with a very slight undercut and a slight taper to match my jaws, I was able to form the tenon here. Now, it's important that the wings of the gouge are straight, because if they're curved, then you won't get as good a shape here, and possibly if they're curved too much, you'll get a skid on entry and you won't get this sharp corner. So very important to have your bowl gouge the right shape, and we can form that very comfortably. Let's do the same now with a 3/8 beading and parting tool. Now, because these two drive centers have slightly different point diameters and shape, I'm going to probably need to retrue this blank up. So that would mean that the outside of this to this tenon would be slightly out, but it's for the purpose of showing how the beading and parting tool forms a tenon on the end. So for cutting the tenon on the end here, I'm using a 3/8 beading and parting tool, freshly sharpened, so it has a sharp edge, and it also has a little burr on each one of the 4 bevel edges, and that can actually help cleaning up the end grain, especially on denser woods. Now, when I'm using this as a parting tool here, obviously when I'm parting in, it's a square chisel cutting a square shoulder. At the end of the cut, I will rotate the tool over to form the undercut, but I must also cut my shoulder at a very slight angle, which means my tenon would be tapered the wrong way. So we'll see as we cut in. And I want to clean up the end grain here. I'm not going to do it as a slicing action. I'm going to do it as a scrape to start with, drop, and then lift in. If you don't scrape to start with, you'll see it actually lifts and throws a fiber. So actually, let's start the wrong way first and show you the bad result. When you use the bevel as an entry point when parting in with any parting tool, it tends to throw the fibers to one side. Instead of keeping them fixed as it cuts through them, they jump ship and they peel to the side of it. And here you can see, quite spectacular, they all jumped ship, barely any came off, and this would be quite a mess to clean up. So when we're parting in with a parting tool, it is important to scrape initially, then try and get some bevel contact. But it's unlikely to keep bevel contact all the way down, so parting tools do some scraping. The parting tool gave a fair finish on the side, nowhere near as good as a gouge, because the gouge slices and peels at the same time, slicing with the nose, peeling with the wing. With the parting tool here, I'm just peeling, so the end grain is satisfactory, but it certainly wouldn't be a finished cut. And because I went in creating an undercut, which I need to, on the shoulder, you can see it actually makes the tenon tapered the wrong way. Now, we don't want to work with a tenon like that. We need to taper it the other way. So to do that, I need to twist the tool over to form the correct shape. So this time, as I push down, you'll see me twist at the end to form the shape. Don't twist too much, because if you cut in very deep, then the cutting edge will be cutting on end grain in the corner and pull. So to complete the tenon here, as I went in, I twisted the tool over, creating a more acute angle and able to undercut the tenon, and I've kept the shoulder undercut. So this tenon is now satisfactory, would be good to use. It now matches the other side. But as you saw with the bowl gouge, it was much faster, much easier, a little less work, and also I got a better finish on the end grain. Should I want to use this surface for something else later, it would need a cleanup. Here I have two similar sized bowls, both with tenons on the base of them. With a spindle block, with the grain running in this direction, same as this little log, whereas the bowl blanks are running in this direction, there's a difference with a tenon. This particular tenon can never be snapped off. There's no way of snapping it off. It will always come out of the chuck as a whole piece. And so I'm going to demonstrate that. And I didn't chamfer the edge, and I have a long contact surface. So I'm going to put it in. So when I bash it hard, you'll see that the tenon will not come off the piece of wood. It cannot come off the piece of wood when the fibers are running this way. So here I'm going to emulate a technical error where maybe I'm cutting up into end grain by mistake and I get a catch. And let's see what happens to the actual block of wood as it comes out the lathe. So it'd have to be a huge catch to rip it off the lathe. And as you can see, it came out. You see the compression marks left on the piece, but it did not in any way pull the piece of wood off. And if we got a catch bad enough to rip it off the lathe, therefore it could possibly go back in, but probably not running true. That's going to be different on this block. So before we do it on this one, let's test the theory out on the one with the chamfered edge. So we tighten the chuck, something happens, we get a catch, just simply too aggressive, maybe it's just a slightly bigger piece, and therefore it's going to force it out of the chuck. Now, when it forces out of the chuck, what we don't want is the wood breaking, because that's unpredictable. We want it to be enough force to take it out of the lathe, but still remain intact and possibly be able to re-chuck it. And there we have it. I've knocked it out of the chuck clean. You can see it's pulled its way out, but it hasn't ripped the tenon off. So we're in good shape. Now, it's possible it could go back on. So let's put it back. We can see where the jaws didn't compress. We'll put that in the same slot. And we're good to go. Now, before I tighten this all the way, one of the problems I have is location. There's a big gap between the jaws on the outer diameter and the bowl. So I know straight away that the likelihood of this running true is fairly slim, especially as I tighten the jaws. Often the wood will move a little bit because it now has free rein to do so, because nothing is restraining it on the front of the jaws. So let's see if I've got it as accurate as I can. So I feel like I have location. And it's running pretty true. So let's tighten it all the way so it's safe for turning. And again, it's running out the bare minimum. I'd probably live with that, but I wouldn't be happy about, again, this space between the jaws and the wood. So although we have grip, we don't have location. And the problem is, as I try to hollow this out, there's nothing to stop the piece from flexing. I have grip by compression from the jaws, but there's nothing on the face of the jaws to stop the wood bending very slightly in the chuck, creating additional vibration. Okay, so now I'm going to mimic getting a catch or something just going wrong with this. And let's see if the piece breaks out of the lathe as a whole like it did for the ash blank, or if the tenon, because it's full length and does not have a chamfer behind it, remains in the chuck. And there we have it. So the failure was much more instant. It was failure of the wood rather than of the grip. And what we created here was the effect that an axe has on the end grain of wood. It simply broke it clean off. And so it didn't take anywhere near as much force. This particular blank, I had to hit it many more times and with a lot more force to create the same effect of removing the blank, except there's no way of rechucking this piece. It's toast. Taking my 40/40 bowl gouge with straight wings, I'm going to do the final cut around the outside of the bowl. And because this is a very small base and a relatively small bowl, then the tenon will have a chamfer on it. And that's important to keep the tenon strong. So here I've produced a tenon that would be good, strong. It has a chamfer on the back so it can't snap off, and it is slightly undercut, and also the shoulder is slightly undercut. That means I get good location, good tightening, and it was cut with a 40/40 bowl gouge with straight wings. No curvature on the wings whatsoever. Allowed me to tuck the gouge into the corner, cutting into side grain. I did not start from the outside of the bowl down. If I went in this direction, I'd be cutting into end grain, tearing the fibers, and possibly a skid on the entry cut as well. Coming in from here, I was able to start very comfortably and roll it right into the corner to produce the detail I needed to mount it in the chuck accurately and with a strong tenon. Again, due to that chamfer on the end on small tenons makes them stronger.